In today's class, we are going to look at series circuits. What is a series circuit? It is an electric circuit with only one path for current to flow. When you have a connection of this form, current flows in only one direction. Here, look at it. Here is the EMF of the circuit. The positive part here is the long one, while the short one is the negative terminal. So the current flows from this positive terminal around this circuit. So this provides only one path for current to flow. And that's why it is connected end to end. Look at this. This resistance is connected end to end with this resistance. Also with this resistance 3. Also with this resistance 4. Also with this resistance 5. So it is connected what? End to end. Current flows in only one direction in a series circuit. Another point you need to note in series circuit is that the current flowing in this circuit is the same. Let's assume that we have a current. A current I is equals to 5 ampere. Ampere is the unit of measuring current. Let's assume that the current here is 5 ampere. That is the current that is flowing in this circuit is 5 ampere. So at every point here across this R1, you will get the current to be 5 ampere. R2, you will still get the current to be 5 ampere. R3, you will still get the current to be 5 ampere. R4, you will still get the current to be 5 ampere. R5 also, you will get the current to be what? 5 ampere. That is to say that the current flowing in this circuit is the same. Now, what about the EMF? Here, look at this. We have the EMF in this circuit to be what? 15 volts. Now, all the EMF here, we have R1, R2, R3, R4, R5. Then the voltage drop here across this R1. Here now, you have this voltage here. You connect your voltmeter here, V, to measure the voltage drop, which is what the V1. You also do the same thing here. Connect your voltmeter and measure the voltage across this resistance too, which is what? V2. You do the same thing to this R3. Connect your voltmeter here to measure the voltage across this resistance. You call it what? V3. So remember that the voltmeter is an instrument used in measuring what? The EMF of a cell or the voltage of a cell. And it's being connected between what? It's being connected end to end across whatever you are trying to what? Measure. In this case is the resistance. You see the way it's being connected end to end. Here, this point and this point to measure this R1. This point to this point to measure for R2. Then this point and this point to measure for R3. So you also do that for R4. You also connect your voltmeter here. Connect it here. Your voltmeter here. Then to measure your what? To measure your V4. So you also connect here to measure V5. Connect your voltmeter here. Then to measure your V5. So when you now add up V1 plus V2 plus V3 plus V4 plus V5, it must give you 15 volts. That is to say that the EMF E or voltage of the source equals the sum of the separate voltage drop in the circuit. Let me also elaborate on that. That means V is equal to V1 plus V2 plus V3 plus V4 plus V5. So if you add up V1, V2, V3, V4, V5, it will give you the total voltage of what? 15 volts. Good. Now, about the resistance. This is the resistance. We have resistance 1, 4 ohms. We have resistance 2, 4 ohms. We have resistance 3, 2 ohms. We have resistance 4, 2 ohms. We have resistance 5, 3 ohms. When you add all of them, they will give you the total voltage in this circuit. I hope that is well understood. But the main point you need to understand when you're talking about series circuit is that the current flowing in the circuit is the same throughout. The only thing that is not the same is the voltage. The voltage is not the same, but the current is the same. The resistance also is not the same. Is that understood? So that means flowing by Ohm's law, which is V is equals to IR. So you see here that current is the same throughout. I hope that is well understood. Okay, let's go ahead. Now here, look at a simple electric circuit. So this is the cell, the dry cell. You have this as your dry cell, that's the battery. So you see, this is the positive terminal, and this is the negative terminal. So this positive terminal is being represented with what? With the long arrow, just like you saw previously. So, and current flows from this positive terminal. So this is the switch. That is called what? The switch. So you can call it the switch, or you can also call it key. You can also call it what? Key. Is that understood now? So you call it switch, or you can call it what? Key. So this bulb here, this is the light bulb. This one here is the light bulb. So this light bulb here can also be the load. So you can also see this as what? As the load in the circuit. Is that understood now? Why this is not the connecting wire? All these are the connecting wire. So also in this figure 2, this is the dry cell battery. Here now you have two dry cell battery, 1.5, 1.5 volts, which is what? 3 volts. It's supplying current in this circuit. So you see, this is the switch, or you can call it the key. So, and this also is the lamp holder. So where you can put your bulb or your load. All right. Now we have rules that governs serial connection in a circuit. So those rules follows Ohm's law. Just like I earlier told you that V equals IR, which is your Ohm's law. So here, for you to get the total voltage, so which is the VT, the total voltage, or you can call it the effective voltage in the circuit, that is what? Serial connection, connected in a serial manner. So it has to be what? V1 plus V2 plus V3 plus V4, and so on and so forth, depending on how many voltage drop in the circuit. So when you add them singly, when you add them together, you get the total voltage. But here, the current is the same. Current is what? Is the same. So that is to say that current, that is the total current, or the effective current, is equal to the current that is flowing through resistance 1. Is also equals to the current that is flowing through resistance 2. It's also equals to the current that is flowing through resistance 3, and so on and so forth. And so on and so forth. So what about the resistance? So your total resistance is now the summation of individual what? Resistance in that circuit, which is R1, R2, R3, and so on and so forth. So these are the points you need to note when you are talking about a serial circuit. The voltage, if you want to get the total voltage in the circuit, it has to be the summation of all the individual voltages in the circuit. But the current remains the same, does not change. Now, also for the resistance, has to be what? For you to get the total resistance, it must has to be what? The summation of all the individual what? Resistance in that circuit. I hope that is well understood. Now, let's look at some common application of what? Of series circuit. Where can we get this applied in real life? You have your flash torch. Your flash torch that makes use of what? Dry cell battery. You will see that the batteries are placed in series. For instance, you can have 1.5 volts, 1.5 volts, which is what? 3 volts. You connect them end to end. They are placed what? In series. So that is to say that the voltages does what? The voltages adds up. 1.5 volts plus 1.55 volts gives you 3 volts. It keeps on adding depending on how many batteries or how many voltages you want to get. So what happens is that as the voltage is increasing, also the current will also what? Increase, because V is equals to IR. So when you have high voltage, you also have what? High current here. So, and once you keep on increasing the voltages, you see that the light of the flash torch is going to do what? Is going to be very bright. So that is the number one application. We also have old-fashioned Christmas light. During Christmas, you put on Christmas lights everywhere to beautify your home. So those bulbs are connected one after the other. They are connected end to end. They are connected in series. That is what happened. So, and the defect of this series connection is that once one bulb spoils, it cuts off all the whole light in the circuit. Why? Because it is connected in series. So once one bulb gets spoiled, their current will not do what? Will not flow again, because there will be open circuit. Current will no longer flow through the entire circuit because one bulb has spoiled. And that is why it is always good to connect connections in parallel, so that if one bulb spoils, other one will also be what? Be on. But in series connection, when one bulb gets spoiled, other ones will not light up again because there will not be open circuits. All right, so let's still go ahead and look at some of the applications. Alarm system. Now you see, if, for instance, if you want to secure your vehicle, your car, all right, you put on the alarm system. What happens is that once your vehicle, everything is closed, is locked, you have a complete circuit. Then current will flow through, and your vehicle is what? Is armed. So once you try to open probably the door or anything, you will see that the alarm will be triggered because current will no longer be flowing. So once current is not flowing again in the system, it will trigger the alarm system. It will start blowing. That is the way it's been done, the alarm system. So you see, it follows what? The principle of what? Serial connection of what? Of circuits. All right, so let's go ahead. Also switches. A switch is simply a break or connection in the path. So you have electric wires connected in the house. So once you turn on the switch, you light up the bulb. Once you turn it off, you switch off the bulb. As you turn it on, you have a complete circuit. You have a complete circuit. The lights, the bulbs in your house will light up. But once you turn it off, that means you have cut off the circuit. That's what we call open circuit. There will not be what? Lights in the house. Let's look at safety device. One of the safety devices we have is a fuse. A fuse has a small resistance and is placed in series. How does this function? The way this fuse function is that once it's in an appliance and the power or the current becomes too high, what it will do is to cut off the small resistance wire in it. So once it cuts off that wire, current will no longer flow, and therefore your appliance will be protected, because we have that power P is equals to I square R. So that means if you now have high current here, of course you know that the wire is going to get burnt. So once the wire gets burnt, it cuts off the current flowing in the system. So your appliance will be protected. So these are few application of what? Series circuits in everyday life. Now let's go ahead and quickly solve one or two problems in this serial circuit. Number one question is this. Find the total resistance of the circuit shown below. Find the total resistance of the circuit shown below. Remember that when you are talking about total resistance, we are also talking about the effective resistance in this circuit. Now you ask yourself, this circuit is connected what? In series, end to end. Look at it here. It's connected in serial. This R1 is connected in serial end to end to R1 and also to R3. So how then do we find the total resistance? So what we do is the first thing you have to do is you write out the parameters. Then R1 is equals to 7 ohms. R2 is equals to 9 ohms. R3 is equals to 21 ohms. Remember that ohms is a unit of what? Resistance. Now you ask yourself, what is the formula that connects serial arrangement of resistors in a circuit? The formula is R, or R total, is equals to R1 plus R2 plus R3. Why? Why are we stopping in 3? We are stopping in R3 because we have only R1, R2, and R3 resistance connected in this circuit. Now we go ahead and add up. R1 is 7, R2 is 9, R3 is 21. So you now have that the total resistance in this circuit is what? Is 37 ohms. So have you seen it now? That the total resistance is the summation of the individual, the summation of what? The individual resistance in this circuit. You add them up. It gives you the total resistance. I hope that is understood. Please always remember this formula, that the total resistance or effective resistance in this series connection of resistors is the summation of the individual resistances in this circuit. R1 plus R2 plus R3, you add them up. Hope that's understood. Okay, let's go to another question. Good. So in this question, it says find the values of V1, R2, V3 in the figure below. That is, it's asking you to find this V1 here. That is the voltage drop across this resistance 1. Then you now find your resistance 2. Then you now find also the voltage drop across resistance 3. Now, how do we find this? Now, let's go ahead and write out our parameters. The first thing is our parameter. Here we have R1 to be equals to 8.75 ohms. Then we have our R2 is what we are looking for. Then we have our R3 is equals to 3.25 ohms. But what else do we have here? We have our E. That is the EMF of the circuit, which is 120 volts. Then we have the current flowing. We have the current I, which is the same throughout. We have the current as 3.75 ampere. Remember that in serial connection, that the current flowing in the circuit is the same throughout. So what else do we have here? Okay, we have V1 is what we are looking for. Then our V2, we have it at 75 volts. Then our V3 is also what we are looking for. Now we have finished writing out our parameter. Now let's go ahead and now solve for V1. Now for V1, here for V1, how do we find our V1? Now remember from ohms that V is equals to IR. V is equals to IR. So therefore, it also follows that V1 is equals to I R1 because I is the same, so we just write I that same way. That's the current is the same. So V1 is now equals to what is the current? The current here, look at the current here. The current here is 3.75 ampere. So we have it as 3.75. Then multiply by R1. Multiply by R1. So what is your R1 here? Since we are looking for the voltage across R1. So R1 is 8.75. So the V1, the value of V1 is now going to be 3.75 multiplied by 8.75 will give you 32.8 volts. That is the value of R of V1. Okay, let's look at V2. No, let's look at R2. For R2. So also you know from Ohm's law that V is equals to IR. So therefore you now have your V2 will be equals to I R2. Now let's make R2 the subject formula because we are asked to calculate the value of R2. Then R2 will now be equals to V2 over I. Because here we have to make R2 the subject formula. So R2 will now be equals to V2 is your V2 will be 75 divided by your current is 3.75. So the value of R2 will now be 75 divided by 3.75, which will give you 20 ohms. All right, let's go ahead and find the value of V3. For V3, we also recall from Ohm's law that V is equals to IR. We are looking for V3. V3 is equals to IR3. So V3 is equals to the current remains the same in a series connection. It does not change. So our current remains 3.75. Then multiply by the resistance R3, which is 3.25. So the value for V3 now becomes 3.75 multiplied by 3.25, which will give you 12.19 volts. So this becomes the value for V3. I hope it is very simple and well understood. Okay, let's quickly check out and play with question number 3. Here it says, find the values of R1, R2, R3 in the figure below. The first step is to write out your parameter. We have R1 is what we are looking for. We don't know it. R2, we also don't know it. We are looking for it. R3, we don't know it. We are looking for it. Then what else is here? We have our current, which is 2.50 ampere. We have our EMF, E, which is equals to 110 volts. We have our V1, that is voltage drop across R1, as we have it as 27 volts. Then we have our V2 as 35.5 volts. Then we have our V3 as 47.5 volts. Now we have finished writing out all the parameters. Then we are now asked to calculate what? R1. So how do we do that? So let's go ahead and calculate our R1. So for R1, then also recall from Ohm's law V is equals to IR. Then we want to find out our R1. So V1 is equals to IR1. So let us make R1 the subject formula because it is R1 that we are looking for. So making R1 here the subject formula, we have R1 will now be equals to V1 divided by current I. So it's not going to be R1 is equals to your V1 here from the circuit and from the parameter we are looking at is 27. Then divided by the current is 2.5. So when you divide that, you get that the R1 is 10.8 ohms. So this becomes the value of R1. I hope you are following. Okay, let's quickly look at R2. For R2, we also have from Ohm's law that V equals to IR. So since you are looking for R2, that means V2 is equals to IR2 is the same thing. Then what is your V2? Your V2 here, the value for V2 is 35.5 is equals to current is 2.5. Then multiply by R2. Then R2 will now be equals to, you divide both sides by 2.5, which you are now going to have 5.5 divided by 2.5. When you do that, you get your R2 to be equals to 14.2 ohms. This becomes your R2. Let's go ahead and look at R3. For R3, it's also the same process. V equals to IR from Ohm's law. Now, since we're looking for R3, so it's going to be voltage drop across R3, which is V3, is equals to I, which is current, R3. Remember that current in series circuit is the same. So your V, let's make R3 solve the formula from there. So R3 will now be equals to V3 divided by I. That is by dividing both sides with I, which is the current. So which is equals to V3 is going to be, what is the value for V3? 47.5 divided by the current is 2.5. So our R3 now becomes 19 ohms. I hope that is clear enough. Okay, let's go ahead to another question. Okay, it says find the equivalent resistance and R3 in the circuit below. You are going to get the total resistance first, then you now find the R3 in the circuit below. Now, how do we get the total resistance or the equivalent resistance or the effective resistance? How do we do that? We simply take the summation of what? All the individual what? Resistance. Is that understood? So let's write out the parameters first. R1 is equal to 7 ohms. R2 is equals to 3 ohms. We are writing out the parameters. R3 is what we are going to find. We don't know it. Then the current flowing in the circuit, which happens to be the same throughout, is what? 5 ampere. Then the EMF of the cell of the circuit is 115 volts. So, all right. Now let's go ahead and calculate the total resistance. Remember that we have that V from Ohm's law is equal to what? IR. Then we have our voltage here. Please remember that V is the same thing as E. So V is the same thing as E. So you don't confuse yourself, okay? So the value for E or V is equals to what? 115, which is equals to the current is what? Is 5. Then multiply by R, which is the total resistance, which is the total resistance here. Then R is now equals to 115 divided by 5. You get it as what? 115 divided by 5 is as 23 ohms. Now, for us to get the total resistance or the equivalent resistance in this circuit, remember that this is a series connection. So you have to be what? RT is equals to R1, R2 plus R3. Remember that. So this R total here is the same thing as R. You can see it as R total. So now let's make R3 the subject formula since we are asked to calculate R3. Let's make R3 the subject formula. So when you make R3 the subject formula, we are going to have that R3 will now be equals to R total minus R1 minus R2. The reason is because this is R3 and this R1 is positive, R2 is positive. So when they are crossing equality sign, they will not become negative. And that's why we have negative R1, negative R2. I hope that is understood. So R3 will now be equals to R total is 23 ohms. Then minus R1 is 7 ohms. Minus R2 is 3 ohms. So your R3 now becomes 23 minus 7 minus 3. 23 minus 7 minus 3. We have it as 13 ohms. Then R3 is what? 13 ohms. I hope that is understood. Good. All right. Let's go to another question. What EMF is needed for the circuit shown below? Remember that EMF is same thing as what? As the voltage. What EMF is needed for the circuit shown below? Find the voltage drop across R3. Okay, so first of all, let's find out our EMF. Then we can now find out the voltage drop across R3. As usual, let's write out our parameters. The first one is R1 is 10 ohms. R2 is 17 ohms. R3 is 4 ohms. R4 is 23 ohms. Then our current, which happens to be the same in the circuit, is 7 ampere. Then our E, the EMF, is what we are looking for. We don't know the EMF. We don't know the EMF. Now, also remember from Ohm's law that V is equals to IR. So this V is the same thing as E. You can also have it as E is equals to IR, is the same. So V is the same as E. They are also voltages, EMF and voltage, they are the same. All right, so let's look at that. E is equals to what? IR. First of all, we now have to get the value for R. We have to get the value for R because before we can get our EMF, the EMF in this circuit. Then but you know that our R is equals to R1, R2 plus R3 plus R4. That is the total resistance in this circuit. So our R will now be equal to our R1 is 10 ohm, our R2 is 17 ohms, our R3 is 4 ohms, our R4 is 23 ohms. Therefore, our total resistance R will now be equals to 10 plus 17 plus 4 plus 23, which will give you 54 ohms, which will give you 54 ohms. Then you also now come, you know that E is equals to what? IR. So it's E that we are looking for. Since the current is the same, our current is what? Our current is 7 ampere times our total resistance R is this 54. 54. So our E is now going to be 7 times 54, which is 378 volt. So that is EMF needed in this circuit. All right. Let's now go ahead and look for our RO3, voltage across RO3. So that is to say we are looking at this. This is our RO3. We are looking at the voltage here. We are looking at the voltage here. We are looking at the voltage here. This is the volt. We are looking at this voltage, which is what? This V3. We're looking for this V3 here across R3. So remember from Ohm's law that V is equals to IR. So V3 is equals to IR3. So V3 is now equals, the current is the same. Remember, the current is the same, which is what? 7 multiplied by resistance 3 is what? 4 ohms. So which is equals to our V3 is now equals to 7 times 4. 7 times 4 will give you 28 volts. That becomes our answer. Okay, that is for that. Let's go ahead and solve other questions. Let's look at question number 6. It says, find the equivalent resistance in the circuit below. Find the current through R2. All right, so let's first of all find the equivalent resistance. After that, we now go ahead to find our current through R2. How do we do that? We do that by first of all writing out the parameters as usual. Okay, now let's write out the parameters. Here, you will have that our E, which is the EMF, is equals to 12 volts. Then we have our R1 is equals to 15 ohms. We have that our R2 is equals to 21 ohms. We have our R3 as 24 ohms. Then what else do we have? I think we are done. Okay. Now, how do we find the equivalent resistance in the circuit below? Remember that this is a series connection, that our equivalent resistance, which is what? R total, will be equals to R1, R2, R3. So our RT, which is the equivalent resistance, will be R1 is what? 15 ohms plus R2 is 21 ohms plus R3 is 24 ohms. So the equivalent resistance, which is the R total, will now be 15 plus 21 plus 24, which will give you 60 ohms, which will give you what? 60 ohms. Now, let's now look at the current through R2. That is current through R2. Now, recall that V is equals to IR. Is that understood now? Is equals to IR. So, since current is the same, so we just have to say current is equals to V over R, which we have, the EMF we have is what? Is 12. Divided by the total resistance we have is what? Is 60, which is equals to 0.2 ampere. This becomes the current through R2. Okay. There is still another way you can also calculate the current through R2. You can still do it this way. You can still do it this way. Here, okay, let's look at this now. From Ohm's law, here now, we can now have here, we have what? V2 is equals to I R2. Is that not it? Then now, let's make I the subject formula. Then I is now equals to V2 over R2. Since we are looking for the current through R2, which is equals to the voltage for R, the voltage across R2 is what? Is 21. The voltage, okay, all right, so let's look at that. Okay, this R2. Okay, let's look at it this way. So the V2 is what? Sorry, let's look at this. Okay, here, the voltage across R2 is not going to be what? Since we know our current is what? 0.2. Multiplied by R2. R2 is what? Is 21. Which is equals to 0.2 multiplied by 21 will give you 4.2. So this is the voltage drop across R2. Now, let's now look at our current. You can also calculate current from here now. You can now say that I, current is now equals to V2 over R2, which is equals to 4.2 divided by R2 is what? Okay, R2 is 21. R2 is 21. You now have that your current I is equal to 4.2 divided by 21, which also give you 0.2 ampere. So remember that the current through the circuit is the same. All right. Let's go ahead and look at another example. Example number 7. Find the current in the circuit below. What is the voltage drop across R1? So as usual, let's write out our parameters. The first one we have there is resistance number 1, which is 15 ohms. We have resistance 2, which is 9 ohms. Then we have our EMF, our voltage, which is 18 volts. Remember from Ohm's law that E is equals to IR. Is the same thing as V is equals to IR. Remember that. So, but before we can before we can look at the current, we have to first of all calculate the total resistance in the circuit before we can go ahead to find our current. So we now have that our R or R total is equals to R1 plus R2, since it's two resistances we have in the circuit. Then R is equals R1 is 15 plus R2 is 9. Then our total resistance or effective resistance is 15 plus 9, which will give you 24 ohms. Now, since we have gotten the total resistance in the circuit, let's now apply our formula. E is equals to IR. So we now have E is equals to IR. Then since we are asked to calculate the current, that's going to be current, making it the subject formula. You divide both sides with R, which is now equals to E over R. So our current is now, our E is given there, which is 18 volts, divided by our total resistance in the circuit is 24, which is equals to 18 divided by 24 will give us 0.75 ampere. All right, since we have gotten the current in the circuit, let's now look at voltage drop across R1. We are now looking at here the voltage drop here. The voltage drop across R1. That's what we are looking for here now. Now let's go ahead and look at that. So you now have for voltage drop across R1, we have that V is equals to IR. V is equals to IR. So since we are looking at the voltage drop across R1, so it's not going to be what? V1 is equals to IR1. Is that understood now? So V1 is now equals to our current. Our current is equals to 0.75 multiplied by R1. Resistance 1 is 15 ohms. So V1 is equals to 0.75 multiply by 15 will give you, it's going to give you 1.25 volts. Okay, so this becomes the voltage drop across R1. Okay, let's go ahead and look at number 8. Find the value of R3 in the circuit below. As usual, let's write out our parameters. The first parameter there, R1, is equals to 23 ohms. We have resistance 2, 14 ohms, that's the value. Then resistance 3, the value is what we are looking for. Then current is the same, which is 3 ampere. The EMF is 115 volts. Right. Now, remember from Ohm's law that E is equals to IR. I hope you know that. E is equals to what? IR. Now, let's make R the subject formula. Then R is now going to be what? E over I. Then R is equals to, our E here is what? 115 divided by current, which is the same, is what? Is 3. Then we have the value for R to be 115 divided by 3, which we are going to get 38.3 ohms. Now, remember that we are asked to calculate R3. We are asked to calculate what? R3. So for us to calculate R3, we have to use the formula for serial connection of what? Resistances in a circuit, which we have that our R is equals to R1 plus R2 plus R3. So it is this R3 that we are looking for. So we make it the subject formula. So it's going to be R3 will now be equals to this R, then minus, this is positive R1 and this is positive R2. When they are crossing over the equality sign, it will now become what? Negative R1, negative R2. So our R3 now becomes our R, the value is 38.3. 38.3. Then minus our R1 is 23 ohms, minus our R2 is what? 14 ohms. So R3 will now be equals to 38.3 minus 23 minus 14, which will 1.3 ohms. I hope that is well understood. Okay, let's look at another question. Find the current in the circuit below. Find the current in the circuit below. Now, the circuit, it has resistance 1. The value is 5 ohms. It has resistance 2. The value is 13 ohms. It has resistance 3. The value is 12 ohms. It has resistance 4. The value is 96 ohms. And it has the EMF or the voltage, which is 90 V. Okay, here now, let's look at the current. Remember, it says calculate the current. E is equal to IR. That is to say that our current I will now be equals to V over R, dividing through by R. So you see, but here we have our voltage, which is 90 volts. But we don't have our total resistance. So we have to first of all calculate our total resistance. You now say, but R is equals to R1 plus R2 plus R3 plus R4. So you now have it that R is equals to our R1 is 5, our R2 is 13, our R3 is 12, our R4 is 96. So when you sum them up, it will give you 126 ohms. Then we now come back here, which we have I is equals to V over R, which is the same thing as E over R. So which is equals to our E, which is the EMF, is what? Is 90 volts, divided by our total resistance in the circuit is 126 ohms. So it will give you 90 divided by 126 ohms will give you 0.7 ampere. So this is the current flowing in this circuit. Okay, now I will leave you to do this by yourself. And please, this example number 3, please solve it and drop the answer in the comment section. Find the value of R1, V2, and R3 in the circuit below. So solve it. First of all, write out the parameters, then state the Ohm's law, the formula, then calculate your R1, calculate your V2, and calculate your R3. Put down the answers in the comment section. Thank you and see you in the next class. We will be talking about parallel connection of what?